Hey everyone! Thank you for joining us for another episode of the Build AI Apps with Azure Database for PostgreSQL series. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our hosts and speakers to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'd love to turn it over for our speakers for today. Thanks so much for joining.
Hello, hello. Welcome everyone to our series about building AI apps with Azure Database for Postgres. This is a 4-part series, and this is actually the last stream in the series. Will be, the grand finale. If you missed any of the previous recordings, you can check them out. They are on YouTube. We'll share the link in the chat so that you can watch those previous talks and learn about everything that we covered in this series. Today, we're going to be talking about building advanced AI agents with Postgres. So we're going to be using Semantic Kernel. We're going to be using new Postgres extensions for Azure OpenAI, for Graph, doing some really, really cool stuff. So I'll just be doing a little bit of it. My name is Pamela Fox. I'm a principal cloud advocate on the Python team. So that means helping developers do stuff with Python, and Python developers love Postgres, which is why I get to play with Postgres a lot. And it's a fantastic database. And our main speaker today is Jonathon. Say hello.
Hi there, everyone. Thanks so much, Pamela. Jonathon Frost. I am a principal program manager in our Azure Postgres team, as Pamela mentioned, and I'm in particular, my team is focused on developer experience and AI features, trying to make Azure Postgres the best experience for developers and for AI workloads.
All right, so with that, we're actually going to go over to you, Jonathon, to start us off with the agenda and our overall architecture.
All right, perfect. So here we go. Excellent. So let me go into our full screen mode. And so, yes, as Pamela mentioned, today we're going to talk about Postgres and Agentic applications. So our agenda today is quite a few topics that we're excited to get through. So we're going to be focusing on one example Agentic application that we built in a VS Code notebook that will take you through a number of concepts using, in this case, we're using Semantic Kernel. And we'll be showing how to extend that and use Azure Postgres to create an agentic end-to-end application in terms of understanding all the pieces of how that comes together. So in our agenda today, we'll be talking about the architecture of this application. Pamela is going to then show us our relatively new VS Code extension for Postgres to understand that we can actually connect to Postgres from VS Code and able to access the data and do other activities inside of it. And then we're going to talk about some AI core concepts with Azure Postgres, and we're going to jump right into the code and show how these areas work. Along the way, we're going to talk about agent programming concepts, in this case with Semantic Kernel, and then we'll also cover some advanced AI concepts for vector-based searches, including semantic operators and GraphRAG. So for the architecture that we're going to be looking at today, this is a simplified diagram of what it is that we'll be walking through, and all this code is available as well. That we'll be giving a link to the repo. And so essentially, from left to right, we're operating inside of a Jupyter IPython notebook that's running inside of VS Code, and we have a semantic kernel that is then running and connecting to our Azure Postgres database. A couple of key things here is that we're, of course, as I mentioned, using semantic kernel, and we are using the agent framework with that. Along the way, then we're creating multiple agent plugins and function tools that are able to perform different actions. For example, we're using the AGE extension for Azure Postgres to provide graph capabilities in order to demonstrate a simple GraphRAG concept. We're also using our relatively new semantic operators to show how we can do semantic re-ranking using our rank endpoint, and how that's one of our we can design it and build it into terms of a plugin in terms of our search architecture. On top of that, we're also bringing in an external web service just to illustrate that when you're building an agent, you can have multiple tools that perform multiple functions, some of which can be doing vector search, some of which can be calling a graph database, some can be calling external web services, all of which to help to build the most rich composite prompt for that agent experience. So that's what we'll be walking through today, and I'm going to hand it back over to Pamela to talk about our data set and VS Code extension.
Okay, so let's check out this data. So I have the code opened locally. I shared the code link in the chat for anyone who wants to check it out. And I'm inside VS Code. I've got the new Postgres extension for VS Code installed. It's a fantastic extension. If you don't have it installed right now, go and install it. You can find it in the extensions marketplace. And you can use it both to interact with local databases and with Azure databases. So in this case, I've made a connection to an Azure database, and I'm actually using a keyless authentication with managed identity in order to connect to it. And I can see what databases are here. So the one I care about is the cases database, and I can explore the schemas. And underneath the schemas, there are various schemas that are kind of used by the system, like the Azure AI extension has its own schema. The Apache Graph has its own schema there for the catalog. But the one that has the actual data that we're going to be using as the base is public schema. And here's the table. So one thing I can do is I could visualize this entire the schema of the whole public of all the things in the cases database, right? So I can zoom in and see, okay, so what we're going to be focusing on is this cases table, which has an ID, a name, a decision date, a court ID, an opinion, and then a vector embedding of that opinion. Now I can also see, okay, what is the top 1,000 rows look like? So I'll say select top 1,000. That'll open up a SQL query. I could limit this, really I only need to look at 100, and then run this query here. And that will open up the table in this data below here. And so that I can look through and get a feel for, okay, this is what the ID looks like. Here's the names of the cases. They're all like X versus Y. The decision date. So we've got things going back even like the 1960s, going way back 1940s. Look in the court ID, look at the actual opinion. That's where the really interesting stuff is. This is the, a big text field there. And then there's also the vector embedding that I generated using the Azure OpenAI extension yesterday. Okay, so that gives us a feel for what the data looks like. Now, one thing that's really cool that I want to show is that we can also say chat with this database. So that will open up GitHub Copilot, and it's connected to that database and says, oh, okay, what can we do with this database, right? So then I could say okay, describe the schema of cases, right? Like maybe I want a little more detail on the schema than what I saw in that visualization. So, this extension knows how to go out and do things, right? It knows a lot about Postgres, about Azure Postgres, like all the different things it could do to try and answer questions. And so it'll use all of its tools to try and figure it out. So in this case, it's like going off and fetching the database context to learn more about it. And this one is an Azure database, so it is making network calls here. So that's why it took a few seconds. So here we have a description. So it says it's giving more information here, like whether it's auto incrementing, its constraints. The vector, this is the one I really wanted to see. The vector is 1,536 dimensions. That's the length of the model of the embeddings that are generated by the model we're using. We're using the text embedding 3 small model, and that outputs 1,536. And and it's even telling me what functions I could use, what operations I might want to use. So it's saying, oh, okay, you could use some cosine similarity on here. And these are all the extensions enabled. So it gave me quite a lot of information there. I could tell it like, okay, let's just summarize like the 5 most recent cases. And what this is going to do is actually do a SQL query. And you can see all of the SQL queries that it creates. It will put in the query history of the extension. So you can yourself run the same query that the LLM ran, right? So I can open this up and say, okay, so in order to answer that question, the Claude model came up with this query, right? Which was, this is actually a pretty basic query, but if I want to, I can run it myself. So you can use this extension both to just chat with the data, but also get SQL queries out of it and kind of do a combo of both. And then in this case, it'll actually do a summary for us because it's an LLM. Like LLMs are good at summarizing. That's great, right? Like we don't have to look through the entire really long opinion in order to understand what's it about. So that's really helpful. But let's do a little bit, because this is not a very fancy SQL query. You're probably not that impressed. You're like, oh, I could write that in my sleep. So let's try to do a little vector search, right? So I'm going to say use vector search to find cases about water leaks using the Azure OpenAI extension and the text embedding 3 small model. It's very important that we're specific about what model we're using because it's not clear from the database, and you have to use the same model that you generated those embeddings with. I think it'd be really cool if we had a way to annotate a column and say, oh, this was made with this model. That's why when I make columns, I actually try to put the embedding model name in the column name. So I'll be like, vector embedding 3 small. And that way I just look at it and I know, and I'm not going to accidentally use the wrong model with it. So let's see, it did a vector search, and we can go ahead and open up that query. And here we can see that it's using the Azure OpenAI extension. So that extension gives a function, which is Azure OpenAI.create embeddings, which takes the model name and takes the query, and then computes that. Uses the cosine similarity operator in order to compute the distance between that vector and the opinion vector in each row, and then gets them all and orders them. And we could even ask the extension to optimize this, and it's great at making more optimal SQL if we think there's something that's not as performant about a particular query. But yeah, so we're going to be using this Azure OpenAI extension in Jonathon's code, so we'll see it going forward. But I wanted to show it here as well to give you an idea for how we can do some AI-powered search of our Postgres database. And I think that's all I wanted to show in the VS Code extension. So we can go back over to Jonathon.
All right, great. Well, thank you so much, Pamela. And that was a really great tip about putting the name of the embedding model and possibly even the number of dimensions in your column name, because that's a great advice, because when you're defining that column, you're then actually specifying the number of dimensions, and then you're essentially kind of binding yourself to that embedding model for that column. So it just kind of helps then for like self-documenting your database code essentially. So that's a really great tip. Great. Okay. So Pamela gave a really great foundation of showing the features that we have in Azure Postgres for doing things like our vector embedding and also doing vector query searches. To kind of take the next step and look at how we can kind of bring this together into an agentic model is I'm going to be walking through how Semantic Kernel works and how we're actually going to be using it in this application that we're going to be walking through shortly. So one of the key things is that we are able to create into our agents this notion of plugins and function tools. And before I jump into that, so the notion of an agent is such that we have the notion of instructions that we define up front, kind of like a system prompt that gives the agent an overall guidance of what its purpose is and what it's trying to achieve. It's a textual paragraph of that. It has a notion of also a service as well, where then what you're actually pointing to, what model are we then using? What LLM is this agent going to be using to do its work? Then from there, most agentic frameworks, whether it's LangChain or Llama Index, have this notion of function tools. The way that Semantic Kernel works is that it has kind of a two-layer system where you have plugins, and those plugins are comprised of function tools. It allows you to compose your agent into kind of multiple blocks, if you will. And so in our case, we're going to be building a collection of these plugins, and each of these plugins are going to have one or a couple of function tools that are able then to run. How they run and what actually happens is it's based upon the annotations on those function tools. It typically, in the case of Semantic Kernel, we have an explicit set of metadata that we assign to each of the function tools. In other frameworks like LangChain, it uses the docstring of the function. But essentially, the idea is that each of these functions have a bit of text that then is evaluated by the model. So that way, during the agent runtime, when a prompt comes in, it's able to determine, hey, I got these 4, 5, 6 functions. Should I run one of these, 2 of these, 3 of these, and then what parameters should I pass into those? And so that's essentially what's happening here. The other key point to mention that is one of the pillars of agentic applications is the notion of memory as well. And there's multiple memory frameworks that are out there. One that's quite popular is Mem0, and that has capability to work with other frameworks such as Llama Index. In our case, we're going to be demoing today a memory framework that's built into Semantic Kernel and actually has a direct integration with Postgres. It is a more simplistic model, but it'll at least demonstrate the concepts of how we're able then to preserve chat history and responses, then able to retrieve them through their own vector-based retrieval during runtime in order to bring back the memories that are most relevant to the prompt that has come in. So kind of walking through this, kind of end to end, to kind of tie up what I just mentioned there about the flow is that, we had the notion of a prompt coming in, the agent is invoked, and then from there, memory is checked in terms of are there relevant memories that should be retrieved for this prompt. And then from there, in our case, if we're using an OpenAI LLM, there's a notion called OpenAI functions mode, which is then used, and that's how the determination of what functions to call. The chosen functions are then invoked, and the responses are gathered. And then from there, a composite prompt is brought together with those responses from those functions, and all of that is then ran through the LLM one more time. And then finally, we have our final response. So we'll be seeing how this works now in our code programmatically. So I'm going to switch over to VS Code now, and we can start walking through this code here. So here, exit presentation mode. All right, great. So this is a notebook that we built originally for a lab, and now we've retooled it and have the repo now public, which Pamela had shared earlier. So all this code and the deployment bicep is available for folks to use. Essentially, the document kind of goes through and talks through the concepts as well as the code samples as well to kind of give both the technical what's going on as well as an instruction of the concepts. So we're going to start with our application by first going past the architecture, which we already covered, and we're going to assume that we already have our requirements file installed with all of our packages. And now we're going to go ahead and we're going to run our first cell, which is our imports. And so let's go ahead and do that. You see that ran. And just to kind of talk through the imports for a few moments, you'll see that we're using some fairly basic ones. We're using CyclePG for our Postgres connectivity. We're using .env for loading our .env file, Pydantic as well as some other basic ones, requests for making our web service call later on. We're also then using, of course, Semantic Kernel, and you can see that we have quite a few imports that we're using for this. So we're using our chat completion. We're using our OpenAI prompt execution settings, but then we're also using our Postgres memory store as well, and that's how we're able to have those memory components that we'll be showing towards the end. So now that we have this ran, we're going to go ahead and get our environmental variables set up. So I already have my env file set up and that has all my endpoints, my keys, my host name for my Postgres database instance, and so that's all been set ahead of time. So run that just to reset it. And now we're going to move down and start getting into the core of the code here. So we're going to be building our first plugin. So so as we talked about, a plugin is a collection of function tools. So you'll see that we have this notion of a class that we're defining called the database search plugin. We have two kernel function and annotations here. So the first is a very simplistic one where all it is saying, let's get the number of court cases back from the database. So as Pamela was showing, we have 377 cases in this data set. And so this is just an example where you can have a very concrete query be a function, where if you have something that's very specific that you know that you're going to want to have and retrieve, you can write that as a direct query and have that as a function. So you can see that's how we are able to open our connection, execute a very simple select count, and then return the results back. And then our other search query that we have here is just to illustrate the concept of, this is before we move into doing vector-based searches. This is kind of just to illustrate the concepts of before we had vector search, when we had fuzzy match and keyword search using the I-like statement. This is an example of performing a search that's using just those capabilities. And you'll see that when we run this, we're going to have only a couple of results come back, despite the fact that we have many cases that will be that should come back based upon the search criteria that we'll be giving. In this case, we're asking about water leaking. And because they're legal cases, the notion of this agent is that it's a legal assistant who's helping to help an attorney build a case about something about water leaking for their client. So let's move on to the next block here. And so when we bring all this together, you'll see that we have now this is our first example that we're assembling our agent. So first we're going to be instantiating our execution settings object, and then we're going to be using that shortly, but then we're going to be creating a chat service in order to, this is where we're pointing our agent to our Azure OpenAI instance. So this is where we're providing the deployment name, the endpoint, and also the key for it as well. And so that's how we're able to connect to the LLM. And then now we're finally going to get into the core piece of this, which is instantiating the agent object using the chat completion agent class. And so we can see that we're referencing our chat service that's going and being passed as the parameter for the service. We're giving it a name. And then we're also giving it the instructions. So as we showed earlier, that kind of system prompt instructions about providing a purpose and the reason for this agent, that's what this parameter here is. You are a helpful legal assistant. Respond to the user with the name of cases, reasoning why the cases are the most relevant in a short sentence of the summary of the opinion of the cases. So we're actually having it perform this for every time. So when it retrieves those cases, it's giving those 3 data points for the responses that it gets. The other key point to mention here is the plugins parameter. So you'll see right now we're only passing in one plugin, the one that we wrote up above, the database search plugin. And then we're also passing in as a parameter the configuration to the database connectivity. Well, as we progress, we're going to keep extending these plugins, and we can keep layering them on to compose our agent into a more complex agent. So let's go ahead and run this. And well, actually, before we run it, I'll give one more important detail, and that is the prompt that we're going to be sending it. So we want to be mindful of that. So we called our prompt user query, and we're asking how many cases are there, and find me 10 cases regarding the notion of water leaking. So that's the prompt that we're sending to the agent. When the agent's called, we're actually going to be printing out the functions that are being invoked. So each of those functions earlier, and then as we go, we're just doing a simple print statement. So that way, as they're called, based upon the prompt, we can see which ones the LLM decided to call based upon the prompt that we're sending it. So I'm going to hit go here, and we can see this in action. All right, so we can see that the agent was called. It decided to call the count cases and the search cases function, which at this point in time is all we have. But as we add more functions, you'll see that it'll make decisions upon which ones to actually invoke. So you'll see that it said there's 377 cases in the database. So it was able to give back that very clear response based upon our function tool. And then it also was able to say that I found 10 cases. Well, this is a bit of a hallucination, actually. It's kind of interesting because it wanted to find 10 cases, but it only found 2 because of the fact that we're using the I-like. So this is an example of we can do better than this. And this is where by using vector search and using some more advanced vector search techniques, we can absolutely get more than 2 cases and get 10 cases. So let's kind of move on to those concepts. So now we're going to talk about semantic ranking and our semantic operators. So when I scroll down here, you'll see that we have this next plugin that we're going to build together. And this is using a new feature that we have in preview for Azure Postgres called semantic operators. And the idea here is that these are direct syntactical operators that you can use in your Postgres SQL queries that to perform AI functions. So the one that we're going to be using is the .rank function today. And you'll see what's happening here is that before we jump into the .rank, we are doing a simple vector search, and we're actually doing 40, not 60. Let's do a quick fix in the comment there. So we're finding the top 40 cases using a standard vector similarity search. So what we're doing here is just like Pamela was showing earlier in how we're doing a search where we have the notion of we're generating the embedding on the fly of the prompt coming in, and then we're taking that and then we're comparing that against the opinions vector column in our table, and we're finding the top 40. And we're just doing a little bit of an extra little syntax here by adding a row number on them to have an ordering of those results. So that's the first part of the query that we're doing here, just getting the top 40 based upon that prompt coming in. Then what we do, though, is that it gets a little more interesting, is we take those top 40 results and then we actually run them, turn them into an array, and turn the opinion column into an array, and pass that into our Azure AI rank function. So the Azure AI, this is the by virtue of having that Azure AI extension installed, we also get these functions. And earlier, I was able to set my endpoint to point to my Azure OpenAI instance. And that was able to give me the ability to use, in this case, I'm using the GPT-4o model, but you can also use cross-encoders and other models as well for doing the re-ranking for even more optimization. And so what's happening here is that we're passing in that array, and it's taking those 40 results, it's evaluating each of those 40 results against the original prompt, and then it's saying, hey, is this the best one? Should this be bubbled up to the top? And then it re-ranks them accordingly. And then once we get that re-ranked list of 40, we then basically just do a query against that to get the top 10. So it's a way of then just kind of optimizing the results from what the LLM gives us back, what the vector search gives us back originally, to use another layer of optimization to have those results. So we can go ahead and run this to instantiate this class and these functions. And what we're going to do now is, before we run this, we're actually going to do even one more plugin to highlight some of these concepts. So this next one that we're going to do is using our graph capabilities of Azure Postgres. So I've already done a few pre-steps, which is that I've loaded a graph version of the database into our same instance of Azure Postgres. And so now what's happening is that we have both a relational table of all of our cases, and we have a graph database representation of that table. One of the key pieces of this graph architecture is that it is keeping track of the citation hierarchy of the cases. And so what's happening here is that we're able then to query and be aware of, for a given case, how many citations are coming into that case. And the purpose of that is we're able to use that as a signal to see if we should boost that case in our relevance for our results. So as we move on here, I can show you some of those concepts. So so here we are with the code here, where we're doing the same approach as the beginning. In this case, we're getting the top 60 cases with doing a standard vector search. But then what we're doing is, this is where it gets quite interesting is we're using a cipher graph query. So by the fact that we have the AGE extension installed into our Postgres database, the AGE extension uses the cipher language to perform its graph queries. And so that's what we're doing here, is that we are taking in those cases, and then what we're doing is we're performing a cipher query to say, hey, give me all the cases and then order them by the count of the refs on those cases. In this case, refs is citations. So we're basically then querying and ordering based upon the citations for each of these cases using this graph query. And then once we then reorder that, we then take the top 10 of those graph results. So by doing that, we're able then to just have another kind of optimization and boosting technique to get those results. So I'm going to go ahead and run this cell so we can define this class as well. And now we can go on. And now we're going to go to the next big step, which is we're going to bring all this together, stitch it into our agent. So if we go back to our code here, we're essentially rerunning a bit of the code we ran earlier. So we're reinstantiating the agent, but we already defined the service. We already defined some other aspects. We can reuse those objects. So we're just going to be reinstantiating the agent. But now what we're doing is we're adding a bit more our plugins onto here. So we have our original database search plugin, we have our semantic ranking plugin, and then we have our graph plugin as well. And so one key thing that I'll just mention really quickly is that if I go back to our plugins, you'll see that I have this notion of description. So this is, as I mentioned, how each of the functions have metadata on them, or why they're chosen by the LLM. This is the key area where this is helping the LLM to determine if this function should be called. So now that we have all those pieces together, we can actually run this. And you'll just notice really quickly the prompt that I have is find me 10 highly relevant cases to water leaking in my personal home apartment from the floor above. High accuracy and high number of citations is important. How many cases are there overall? So I'm asking quite a few different things, but you'll see that I'm saying high accuracy and high citations is important. And the reason is that I'm kind of nudging it to do both a semantic ranking query and the graph query as well. So we'll see what happens when I run this. All right, great. So the count cases was called because I asked for how many cases. The graph cases was called because I mentioned that high number of citations is important, and is also calling the semantic re-ranking because I said high accuracy is important. You'll notice that this will take a little bit of time to run because I am using the GPT-4o model. If we're using a cross-encoder model, this would be a little bit faster, a little more optimized. So let's take a few more seconds for this guy to run and perform the re-ranking portion.
And is Semantic Kernel running all those queries in parallel?
It is. That's a great question. Actually, I think it's doing some parallelization because it's able to. I've seen it in the past where it appears to be, but then again, I'm not sure on the internals. That's a great question. Yeah. So now that we ran this through, you'll see that we had a number of cases is clear, 10 relevant cases, and now we have through 4. Then we actually have more. If I go to scroll element, we actually go down to 10 cases. So it was able to find all 10. And what's important to mention as well is the cases themselves. I happen to know this data set now pretty well from having worked on it for a little while, and definitely the Levette case is for sure a very relevant case to this question. Imperial Candy Company as well, United Mutual Savings Bank. So it did a pretty good job. These are cases that are definitely really relevant, looking at the actual details of the opinion.
There's a good question related to this are the agents generating custom SQL queries, or are they using predefined queries?
Yes, in this case, they are using predefined queries. And I can show you an example of where that's actually happening. So let's scroll up here a little bit. So in the case of the graph query, we are this is a query that is predefined, and we are let's see here if I can show the detail that would be helpful. Yeah, so so essentially the prompt itself is the parameter that's coming in. So you'll see that everything here is predefined, except that we have the %s, which is showing that that's coming from the prompt coming in. So it is deciding which piece of the prompt to send into the function, because obviously if we sent the whole prompt, that would not be the best result. So there is some intelligence happening where it's deciding to take this segment of the prompt and pass that as a parameter, but the rest of it is being hard coded. You could theoretically go a bit further and actually do something to actually have a natural language to SQL construct, where you could actually define that inside of your function tool if you so decided.
Yeah, I'm curious what you think about that and what the safe way of doing natural text to SQL is, because I get asked about this all the time, and I'm like, well, just be very, very careful about generating SQL on demand.
Yeah, exactly. You definitely open yourself up to injection attacks, and many other things as well. So there's always that classic cartoon of was it little Bobby Tables? Yes, I always think about. and so yeah, that's a really great point. So I think that's where you have to have some safeguards and actually have some logic to probably do before the query is ran, to do like a pre-checking stage. Because you are able to then, if you are having the query be generated programmatic or automatically by the LLM, as long as you're actually doing the execution yourself programmatically, you could do a pre-check stage.
Mm-hmm.
Great questions. All right. So now that we've seen some fairly advanced searching techniques using both graph and semantic re-ranking, we can talk about a few more details as well, and that is the notion of adding, I believe our next one is going to be our weather plugin. So because we are talking about water leaking, and this is a legal assistant, the notion of, hey, on a certain date and time in a certain city, maybe how much rainfall there was could be relevant to this case and could be something that we'd want to bring into our research and our evidence. So that's what we're trying to simulate here. And so essentially what we're doing is that we're writing another plugin, calling it weather plugin. And we have another function with another description. And you'll see that we're calling it get historical rainfall. And then you'll see that something that we're doing here is that we're actually then having the description, but we're also being very clear about what it's actually doing here. So you get the precipitation in millimeters on a given date and location, latitude, longitude. So this is actually one example where it's pretty neat. By passing in the actual city and state, the LLM is able to convert that into latitude and longitude for us on its behalf. And we also give it a little bit of a hint here in the doc string in terms of putting the date in this format, and the longitude are in the WGS 84 chords data structure. So by giving those hints in the doc string, the LLM is able to help to translate that for us.
I do think that it would be best to have a geocoding API, because this does work with Seattle and with the big cities, but I just worry people don't know that there's like geocoding APIs that know how to do this, and you could still use it as a tool, right? So you would add another tool that was like, geocode, and the agent would first call the geocoding tool, passing in the city name, the address, whatever, and get back the exact latitude, longitude. It is quite neat that it does happen to know the latitude, longitude of many big cities, but just so you know, there are geocoding APIs out there that are great. That would be good to add to this agent's arsenal if anyone is developing something with latitude, longitude.
Yep. Yeah, that's a great tip. Yeah, you are kind of rolling the dice a little bit that hopefully the city that you chose is going to be found out. So if you want to be a little more explicit, you can definitely, yeah, compose in, layer in another function tool that performs that directability. So that's a really good tip. So as we move on, you can see, let's do our standard print to show that this function was called. Here's the actual URI that we're hitting for that open public web service endpoint. The params, the actual highly structured params that we're passing in that are being converted from the LLM and being passed in here. And then we're just doing our request.get to call the endpoint, and then we're able to get back our data in a JSON format. And then we're able to then actually then return that and actually then say, on this this date, latitude longitude was blah, and so we're able to extract that from this area here. And so now that we have this, we can run it, and we can then look at reassembling our agent one more time, and as well as we can look at our prompts. So I'm going to click go to reassemble our agent, and you'll see that we said what was the rainfall on this date in Seattle. I need this for evidence. I'm also asking about citations and cases. And so we can see what happens here is that we can see that the historical rainfall was called, the search graph cases was called, and it says on this date in Seattle there was 5.1 millimeters of precipitation, which could be relevant in demonstrating. Let's see here, my horizontal scroll bar. Let's do this scroll element. There we go. Should be relevant in demonstrating potential water-related issues. So it's actually thinking for us as a legal agent, and because of the system prompt that we gave it earlier, because of all this data, is trying to be essentially a legal assistant and providing us with these data points. So now that we've kind of composed all the pieces of our agent, all the function tools, the last piece that we wanted to talk about is on the notion of memory, and the idea that we want to then preserve the past conversation that we had with the agent, and so that way, as you're chatting with it and having multiple back and forth interactions, is able then to build upon those chats and actually then use that for context. There's definitely a few ways of accomplishing that. I'll show one way of accomplishing that using this, what's built into Semantic Kernel, let's see here, and as I mentioned as well, there's other frameworks as well. So Mem0 is one that we're finding is becoming quite popular. And I'll just kind of give a brief comparison contrast. So with Mem0, some of its abilities is that it's able then to actually infer from the prompt what is actually a memory. So that way, when a prompt comes in, it says, is this something that I should keep as a memory? And then if so, it'll then preserve it and hold on to it. And then on the reverse side, it'll bring back a memory based upon the prompt. So it has a bit of intelligence in terms of that preservation. In this case, what's happening is painting with a bit of a broad brush, but it's great to illustrate the concepts. And that is every prompt and every response is being held in memory, but they're being stored and vectorized into a separate table. And then upon retrieval of when a new prompt comes in and we're looking at the memory store, it's using the new prompt as a query to say, are there memories from the past that are relevant to this prompt, and should I bring those in? So you'll see what's gonna happen here when I run this. And so I'm gonna simulate kind of a conversation going back and forth, starting with some very simple points and then kind of building it up from there. But before I jump into that, just kind of show how the code works is that we're going to create yet one more connection string, just using our previous data points in order to connect to this new memory database instance. We're going to instantiate this notion of a memory store, and we're going to be passing in that connection string so we can connect to it. We also have to give the dimensionality of that because, again, we're going to be re-embedding and re-retrieving, and so we're going to be using the same embedding model we used previously that Pamela covered, the text embedding 3 small, and we're able to do that by instantiating this notion of an embedding generator and pass in that deployment name, and then also our endpoint and our key for our Azure OpenAI instance. We're going to bring all that together by instantiating a semantic memory object by passing in the memory store and the generator. So now we can bring those into one component. And then what we can do here is that we're going to then say save information up front. So now we're saying that we're defining a collection, which in this case is basically a table. And then we're passing in the query that we had. So we're passing the prompt, and then we're holding on to that for memory. And then what we're also doing is that at the same time, we're getting a notion of recalls. So we're saying, hey, based upon that query, please go back to that collection and find the top three items, the top three memories that we want to bring back. So that's what we're doing there. And then from there, we're able then to build a memory context from those recalls. And then we're able then to construct a kind of a pre-composite prompt, if you will, where we're taking our prompt that we had, and then we're saying, here's the things we discussed before, putting in that memory context. So that way, when we're interacting, we just put in our prompt, but it's able then to grab the memories and do that on our behalf for us. And then from there, everything else is basically the same, where we call our agent.getResponse, passing in a prompt, and then we're able then to print out the response from the agent. And at the very, very end, we're just saving the memories to make sure that we're capturing everything from that final response. So that's effectively what's happening here for all these steps. So I'm going to just modify this slightly by starting with a very basic prompt and say, I'm a real estate lawyer, and we'll see what happens here. Kind of simulating a basic chat interaction. So we say, here's the things we talked about before. So it's just capturing that first time. And it says, got it. It's a real estate lawyer, may frequently find deals involving yada, yada. And it's like, okay, great. So now it knows a little bit about me and what I'm trying to achieve. And so now we can go ahead and move on to the next one and say, my client has lived in their apartment for 10 years. So let's go ahead and hit go for this. It says, understood. If your client has lived in their apartment for 10 years, this could be relevant to several legal issues: landlord-tenant disputes, renting control, civilization, tenant rights. So it's like, okay, great. Starting to kind of build up a conversation and build a little bit of context. So now we can go on and do it one more time. And now we can actually say, go back to the prompt that we were using previously, say how many cases are there, high accuracy is important, and find me 10 relevant cases, and we'll see how it responds. So we're calling our functions that we had previously, our count cases, our search graph cases, and it says, here's the things that we did talk about previously, and it says, okay, here's the number of cases, and it's able to provide the cases. But this time, you'll notice that the results are a little bit different order. And what's happening here is that it's using the fact that we had the notion of a real estate attorney. It has actually adjusted the case order to make them even more focused on that. You can see that like this first one is talking about construction defects, and this other one is talking about damaging property due to storm drainage. And so what's happening here is that we're actually getting cases that are more relevant to the context based upon the chat history that we had before. So that's pretty much all the core content that we had in terms of code and in other areas. So I'll take a pause here and maybe see if we have any questions or things that we can help address.
Yeah, we just had a good question, which is, we generated the vector embeddings for the opinions, and we stored that in the opinion vector column. But what happens if the opinion column gets updated, with some new value? Like, how do we handle updating that embedding column? What's the right approach there?
Yeah, that's an excellent question. So there definitely has to be a runtime lifecycle when it comes to your embedding. So in the case, if it's something with legal cases where it's a fixed in time construct, there you'd be kind of in an okay place where you can run it one time and then keep retrieving it. But if there were new cases coming in, you have to think about that data pipeline and be able to then grab those new cases and then embed them as they're being inserted into your database. One technique for doing that is that you could actually write an insert trigger where upon insert of the textual opinions column, you could then actually run the Azure AI extension that we have in the embedding function and have that as part of the trigger, so it's automatically done upon insert. Otherwise, for other data types, you might want to think about is that if there's cases where the data does change and the row changes, that'd be a case where, again, you could be looking at a trigger that could handle that if that textual column changes, or that could be part of your data pipeline where upon the data being inserted, you could have it programmatically perform that revectorization.
Yeah, that's I like the idea of the triggers. I need to try that out myself. Because it can be a real pain. And the big thing is also when new embedding models come out, right? Like for a long time, I was using text embedding 8002.
Yep.
That was like kind of the original big model. That's what I had everything in. But then the new models, the text embedding 3 small and text embedding 3 large, they're much better. There's also some like open models like Nomic, which is quite good. And like, depending on like what language you're using, other models might be better. So yeah, there's also that, which is like, oh, it's time to re-embed everything. And that's also part of why I keep the column name in there, because then it's like, well, I had this one before, now I'm moving to the new hotness.
Yep, that's a great point. And actually, I mean, the trend seems to be too that the dimensionality is increasing as well. So we're at 1536 for text embedding 3. We're going to see. I think I've seen some in the 4000 and 5000s for some of those newer open source models. So we'll see how far we go on this.
Yeah. So text embedding 3 small, that's on the smaller side. Text embedding 3 large is 3072. And that one, actually, there were some issues with that because I think originally PG Vector couldn't hold that large, but they did make a change recently. And I think Azure Postgres also made a change recently, right, to support that.
Right, and we also have our disk ANN index as well, which is able to support the higher level dimensionality, which is a topic that we haven't talked about very much. Just to quickly touch upon that, in talking about retrieval optimization, we didn't talk about indexes, but there's another important topic, and that is where because we're in a relational database, we are creating these embeddings, these vectors. They're living in a column. So just like years past, when we talk about care and feeding and optimization for relational tables, and building the proper index for the proper data, the same applies to vectors. And so we have for Azure Postgres this notion of the disk ANN index algorithm that we were able to bring in from our friends in Microsoft Research and optimize it and integrate it into Azure Postgres. So that way you can add that index onto your vector column, and that will help you with even faster and more optimized retrieval. The code is quite simplistic. All the queries that we showed, that Pamela showed earlier with the cosine similarity, and that we showed in this cosample will work with disk ANN. The only upfront step is you have to basically install the extension, and you have to run one line to generate the index on your table.
Yeah, definitely. Once you have, once you're just putting anything into production, you should be using an index for your vectors in order to have performance search, because otherwise it's doing a brute. It's doing every single calculation, which is it's unnecessary, right? So
Right.
You can use disk ANN on Azure. You can't use disk ANN locally yet, as far as I understand, right?
Right. That's correct. Yeah.
But so locally you can use the H and SW index. Also locally, maybe you're okay with the slow queries. And then in production, you can use disk ANN. Let's see, we had a question like, okay, so you have this like cool notebook that you put together. What does it look like to turn that into like a user-facing application? What sort of additional configuration or considerations should people have when they're making this into something for people?
Yeah, that's excellent point. And we actually have 2 solution accelerators that we are in the process of launching right now that are using a lot of these same concepts, and they are agentic apps built on Azure Postgres. They have a full UI and a full backend. So things that you'd want to think about, the architecture that we've been kind of using for these solution accelerators is one where you have the notion of a backend. In our case, we're using Fast API in Unicorn and hosting that into an Azure container app. So it's just basically a backend running with exposing those Fast API REST endpoints. And then that code essentially would look like what we have in the notebook, where you can imagine these the semantic kernel code, the database plugins that we wrote, that would be living on your back end, and would be retrieving your REST endpoint requests coming in. Then from your on the flip side, you would have your front end, and what we built in our solution accelerators is that we're using Node.js and React for our front end, and then we're able then to build a kind of fairly simplistic but comprehensive user interface where you have multiple pages and some state management and maybe a chat box interface, and essentially then all those interactions are then hitting your RESTful endpoints onto your back end, and that's also then running either in the same or in a separate container app as well with Node.js. So that's essentially kind of the high level architecture of one pattern that we've been building and we've been seeing our customers use as well.
Do you also see people building MCP servers, or are they not doing that yet due to the security issues?
Yeah, that's a new, really keen topic right now. So we actually have an MCP server for Azure Postgres that we have released the code base for on a repo in order to simply, if you want to run that yourself and be able to connect into a Postgres database from an MCP client. In terms of our customers, that's something that we've been talking about with our customers, but we have yet to, I think, see a fully working version of that. But I'm sure it's coming, because definitely MCP and also A to A are definitely where things are going in terms of creating this kind of even more cross-composable agentic model because that would be, I mean, and to that point, a lot of what we showed today is could have been restructured into an MCP architecture. So the weather web service, for example, that could have absolutely been an MCP server that we could have been pulling into our agent model, as opposed to hard coding it ourselves and building a function tool.
Right. Yeah, and one thing I also want to add with the, when you're putting this into production is thinking about the security and the data that you're using. A lot of the use cases, you're going to want some sort of user login, something to gate the access to the application. So that so there you could use Microsoft Entra with, if they're using a Microsoft account. You could also use Microsoft Entra external ID for with other identity providers, but generally it's all via OAuth, right? So using OAuth in order to restrict access to the application, and you can also host it inside a virtual network, right? That would be the other option if your company is on a virtual network and uses a VPN to get in, and Azure Postgres supports fully the virtual networking, right?
In private link. Yep, exactly. You got it. And that's a great point about the authentication. And another framework to look at would be the MCEL framework as well for doing authentication. And full integration with Entra ID. As Pamela had mentioned earlier in her demo, she was logging into Azure Postgres from the VS Code extension using her Entra ID, passwordless. And so that same pattern could be used with MCEL in a web-based application as well.
Yeah, so just definitely think about security whenever you're doing anything with databases. All right, let's see if we have any other questions. I thought a good question was like, all right, if somebody wants to start building agents with databases, but they don't think of themselves as a SQL expert, do they need to learn SQL? How important is it to learn SQL now?
Oh boy, that's a great question. Well, I could answer it two different ways. One is, on one hand, if you're doing something like using, for example, an MCP server or similar for Postgres or that approach, then essentially what you're doing is that you're just asking questions about your database and getting your responses back. The other approach is that what we showed today in our code samples is that those were concrete SQL queries, some of which were a little bit more complex. In that case, if that's the road you want to go down, one great approach is actually what Pamela was showing with our GitHub Copilot for our VS Code extension, where that's actually a really good learning tool as well. It's funny, when I was working on that feature and we're getting it out for build, I thought to myself, my gosh, back when I was a younger man and learning coding when I was a teenager, I would have loved to have this assistant and this helper to guide me through all these aspects. And but if if in terms of just having it help you write queries, is able to really take your idea and your thought and convert it into a SQL query for you, and then after it creates it, you can have it explain it back to you line by line what's actually happening. So I'm finding it to be pretty much one of the best learning tools, more than any tutorial out there can be.
All right, that's great. Yeah, those are great tips. And using LLMs to learn instead of having it just blindly do what what we want to do.
Yeah.
Especially if you're going to be putting something into production, you do want to actually understand the code, right? And make sure it's going to be performant. There was another great question, which is what other use cases are there for the kinds of concepts that you showed today? Like what are customers doing that you've seen? What are other popular scenarios that you're encountering?
Yeah, that's great. So yeah, the scenarios that we're seeing are really vector search. We're seeing customer service applications, and really what we're looking at there is high scale, so scaling up the vectors. It's as Pamela mentioned, with indexes and with enterprise scalability, it's it gets to a point where you're fine for the first few thousand vectors, but when you start getting to the millions of vectors, that's where we can start to see that you need to have the proper indexes, you need to have the proper database architecture, possibly partitioning. And so that's what we're seeing right now from a lot of our customers is understanding scale, understanding optimization, where the other piece is accuracy. And that's the other area that we're helping our customers with. And that's where the agentic model can also help, where by having the two pieces together, you have the scale, the database architecture on indexing on one piece, but then you have the way that the requests are coming in and the way that the prompts are coming in and the way that you're handling the searches, is that by having an agentic model, you're able then to optimize the prompt and have a toolbox of function tools, as opposed just to relying on a simple vector search in order to have a better experience for the end user of the application ultimately.
Awesome. Okay, I think those are the big questions we had. Is there anything more that you want to add before we go to our final wrap-up slides?
No, just want to say thank you, Pamela, and thank you everyone for the time, and really appreciate all the questions.
Awesome. Okay, so if you want to keep learning on the topic of learning, always be learning, we have a learning path about building AI apps with Azure Database, and we'll share all these links in the chat. We've got a blog that has all the news and updates about Azure Database for Postgres. So if you are using it or thinking of using it, you should subscribe to that blog using whatever feed reader, whatever mechanism people use to subscribe to blogs these days. We sign up for an email. And then, of course, if you haven't started off with Azure Database for Postgres yet, you can try it out for free and take it for a spin and see if it works for your scenario. I really like it. I use it for some of my side projects as well, and I think it's a great database. As in, this was our final live stream in this 4-part series, but we have all the recordings available for all 4 talks. So if you missed any of the earlier ones, you can go back on the series page and watch them on YouTube and catch up on everything. And if you have any questions or you want to share something you're building, do join our community. We have an Azure AI Foundry Discord and an Azure AI Foundry GitHub discussions where you can ask your questions, do a show and tell. I did a show. I love show and tell. I posted one of my projects as a show and tell in the discussions the other day. On Discord, we've got AMAs, we've got office hours. I actually have my own office hours coming up in 2 hours on the Discord. So that's if you have any questions about Python and AI, then I will do my best to answer them. So come on over to that Discord. We'll share the link for that one, for all these forums in the chat as well. And yeah, and that's what we wanted to share with you. I see there's a question. Can we get free Azure credits for experimentation? Well, Jonathon, do you want to explain the different kinds of freeness that exists right now?
Yeah, so that's a great question. So right now, I mean, so our VS Code extension that we demoed, that is free. So with VS Code, you can download that, of course, and then in the marketplace, you'll find that extension. And then for Azure Postgres, there is a very inexpensive tier that you can use to get started. And then as well as there's other tiers that you can also do for entry level for Azure OpenAI and AI Foundry as well.
Yeah, if you're brand new to Azure, you do get free Postgres for a year, right?
Oh, that's right. I almost forgot about that. So thank you. That's right. And actually, when you go to the Azure portal, you'll see how to get that.
Yeah. So if you have not ever made an Azure account and this is your first time making it, then it is part of that first year. So you can do some experimentation with that. And I'll just go ahead and link to the VS Code extension, because the VS Code extensions, like the great thing about that is it does work with local databases, and it even has built-in ability to make a local database. So if you've got Docker running, it'll actually make a local database with your Docker, and that's really cool too. So there's a lot you can experiment with just local Postgres. What you do need Azure for is if you want to try the Azure OpenAI, the Azure Rank that you showed, or DiskKNN, those are all currently only available on the deployed production Azure.
That's right.
All right. So that is what we have for you today. Thank you for all the great questions and comments, and Jonathon for sharing his knowledge and his notebook. And I learned a lot from it. I hope you all did too. And we'll see you at future streams. Bye, everyone.
Bye. Thank you.